Today, we will be looking at how to improve your badminton skills by understanding the physics of the sport. Most of our statistics came from Lee Chong-wei's performance and or improvised to create a frequently occurring situation. In this following situation, you will be watching Lee Chong-wei perform the fastest smash at 417 km per hour in a matter of 0.5775 seconds. Today we will be looking at what is required to perform a good smash. Through research and experience, we know that for a smash to be successful, it requires players to have an understanding of trigonometry, kinematics, and energy. A badminton court has dimensions of 6.3 meters in width, 13.4 meters in length, and includes a 1.5 meter tall net. In this situation, we'll be looking at the trigonometry of the birdie to understand the concept of angle of attack. By using the highest contact between the player's racket and the birdie, also the distance of the player from the net, we can determine C, in other words the hypotenuse of the trajectory of the birdie. At the end of our calculations, we will end up with a hypotenuse of 4.914 meters. With this, we can use sine law to find the angle of attack. It will come to be 66 degrees, therefore making the angle of attack 24 degrees towards the ground because of trigonometry laws. Now that we have the angle of attack, we can find any variable from velocity to time and displacement with Mr. Lee's statistics. As mentioned below, we know the angle of attack and the final velocity of the birdie, time of impact, displacements on the y-axis, and some of the displacements on the x-axis. The displacement in the x-axis is starred because we are missing the distance of the birdie on the opponent's side of the net. By using sine law, it can be solved for the second half of the court. It ends up to have a total displacement of 7.922 meters on the x-axis. With that out of the way, we can use SOHCAHTOA to find the final velocity of both x and y axis. It comes up to be 46 meters a second on the y axis and 102 meters on the x axis. Because we have 3 out of the 5 variables in both of our x and y component charts, we can use one of the big 5 equations to figure out the initial velocity of the birdie. We will end up having an initial velocity of 0.26 meters a second in the y-axis. The equation we are using is d equals v2 plus v1 over 2 multiplied by time, leading us to have an initial velocity of 0.27 meters a second on the x-axis. Now that v1 is solved, we can solve for acceleration using any equation. We chose to use d equals v2 multiplied by time plus acceleration multiplied by time to the power of 2 divided by 2, giving us an acceleration of 13.8 meters a second squared on the y-axis, and a whopping 1011.68 meters a second squared on the x-axis. For a smash to be successful, you need to have an understanding of basic physics, player positions, and a strong enough exerted force on the birdie. Also, with this information, it could be possible to determine forces such as friction and find the energy required to perform a smash at any given efficiency. Thank you for watching, and smash on!